Hey, I'm Peter Todd. Thanks for joining me at this ungodly hour. Let's see, someone have that up? There you go. So, yeah, I mean, just say a bit about myself. I've been working as a Bitcoin core developer for a while now, and I also do consulting work for a variety of clients. Treechains is kind of my most recent interest in terms of making Bitcoin scale up. And let's see if this works. You know, and I think yesterday we saw a lot of people talking about using consensus systems for something other than just payments or other than really what Bitcoin itself can do. And at the same time, of course, we also want to go scale up payment volume. You know, scale up how many transactions per second Bitcoin can do. And, you know, there's your features. And then finally, the last concern I think everyone has is how to go keep the whole system secure, regardless what we're using it for. So, if all you care about is payments, I think we do have some more limited solutions to go address all these issues. You know, with your off-chain payments, your micropayment hubs, you know, you're certainly able to go and make Bitcoin scale up in the sense that you can have a large number of payments, you can make them instant, but fundamentally all these solutions, as clever as they are, seem to be only based on payments. And while the security is good, based on clever cryptography and economics, again, it's pretty limited in what it can do. We've also heard of embedded consensus systems like Mastercoin and Counterparty, and unfortunately, they're all based on putting data into the Bitcoin blockchain itself, so inherently they're always limited to your 7 transactions per second, roughly, that Bitcoin has. Now, they do offer a blank slate. You can go and build whatever you want with them, but you do have this scale issue. We've seen a lot of people trying to really solve both problems. Alt-chains are your obvious example where, of course, if you create a chain from scratch, you can really pick whatever rules you want. However, security with an alt-chain is kind of tricky. I mean, with consensus systems, security is really how many people go use any given system. You know, your attacker, your 51% attacker, as everyone hears about, well, if I took all of you guys and divided each table into one little alt chain for one particular purpose, well, of course, the size of an attacker can be quite small to go destroy the given system. So we got to do better than that. And merge mining is a similar idea compared to simply creating a whole new system where you say, all right, what if we sort of reuse the proof of work for one system like Bitcoin to go secure another system? Namecoin's a good example, where the rules for a Namecoin block is essentially prove to me that you attempted to mine a Bitcoin block. It doesn't matter whether or not it was valid according to the Bitcoin difficulty rules, but if it reached the Namecoin difficulty rules, it's a valid Namecoin block. Theory being you can go have miners who are already devoting their hashing power to Bitcoin to go secure Namecoin. Unfortunately, of course, that's a converse. I mean, it may be free for you to help secure Namecoin, but it's also free for me to go attack Namecoin. So I would call that a false sense of security. But can we do better? And really what we want is a system where everyone's working together. So this is where my idea of Treechains comes in. And I think it kind of comes from my work with Mastercoin and Counterparty, and this notion that, you know, maybe you don't really need rules enforced by mining itself. Maybe we can create a simpler layer. And if the layer itself is something without rules, you can go and push all this validation client-side. Equally, it also means that no one has to go ask permission to go develop new things. I always like to go bring up the example of Mastercoin. As much as people said, Mastercoin's bloating the Bitcoin blockchain and so on, the reality is nobody could say no to them. Nobody could really go stop them from doing what they were doing. And I think that's a very good thing. It really lets small groups of people innovate. And equally, I mean, as an example with merge mining, you can go and make this same sort of argument. You can go and create your new system, but again, it's a matter of can you get the critical consensus before it's secure. So let's go look how it actually works. So my idea with Treechains is, let's go start with a linear blockchain. And here we have a block. And in the Bitcoin system, of course, one block builds on another, and so on, and so on. Now, how can we go split this up? Because if we have this linear blockchain, everything's going in that one chain, and that's not going to scale. So let's go start again. Where'd that go? There you go. Rather than just having one linear blockchain, let's go add more chains coming off from it in the structure of a tree. Here we have our 3 blocks forming the root linear chain, and then we've got another 2 coming off of it. And you can think, if you're familiar with the mechanics of merge mining, we're essentially putting a reference for one blockchain into another. And here we're saying, okay, we'll have a root chain, and we'll go have another chain underneath it that's referred to by the previous one. And as time goes on and mining happens, we can go and build upon that with more blocks, and so on. And eventually end up with a structure which, I'll admit I had a hell of a time trying to go and actually draw this, but you can visualize it as sort of a 3D structure of your root chain up top and then sort of other chains branching off. And then you got to ask, well, how would you actually use this? Well, remember the example of your embedded consensus system where you're publishing data in a chain and you're coming to consensus over what data was published, and then you're applying rules to it to create a system that can go represent something. Well, you can do this exact same thing in a tree of blocks, because in any given system you can say, all right, for something to happen, we will define some place where it needs to happen. As an example, if I'm going to go spend some money, I'm going to go prove to you that that money is real by saying, look, there was no other block within that part dedicated to that transaction output where I made a valid spend. And the only people who need to go care about that is the person I'm giving that money to. So if that goes in one part of this tree, well, I can go provide a proof corresponding to that part that consists of me showing you, all right, these blocks, say 3 levels down to the left and to the right, did not contain spends of the funds I'm going to give you. Which can be how a payment system can work. I'm essentially proving from one side of the tree to the other that money validly was able to go move across. I'll also go point out, maybe even easier to grasp, is if you're familiar with Bitmessage. In Bitmessage, we go use Proofofwork to make messaging system. And the Bitmessage algorithm is very simple, where if I'm going to go send a message to the community, I go do some work on it as an anti-spam thing. Similar sort of proof-of-work algorithm to Bitcoin. And I just show that I burns up some computer power, making that message valid. The problem with Bitmessage right now is, well, there's no blockchain, therefore, how do you actually know your message ever got anywhere? You know, I can go and broadcast my message to my nearest peers, but there's no indication that anyone else got that. So if you add a blockchain to this, well, I can know people got my message by the fact that it's now built upon by other people. And I can go look at the total work done subsequent to when I published it. Well, with a Treechain system, I now can add another layer to that, which is to say, going back a second, I can go say that we'll split up where messages can go so that some amount of work was done to go and do a message that was broadcast to everyone, say a little less to broadcast to fewer people, and so on. And then payments and other financial innovations is then just a matter of exploiting the fact that you can go and devise orderings for how transactions are related to each other so that we know what one thing came before another and so on. But I suspect there's going to be a lot of questions, so I'm going to deliberately leave things a little more open. Open up to the floor.
Yesterday the idea from Vizor about expanding the linear blockchain by adding other chains. Can you maybe compare and contrast, or what are the benefits of each?
Well, I have to admit, unfortunately, you missed that talk, but I can go and say that from what I remember reading that paper, in general, it's not dissimilar what I'm doing and what they're doing. I think they're more focused on the notion that eventually all the chains will come into consensus, whereas I'm focused on the notion that we should have a system where we do not assume that all relevant knowledge about the blockchain ends up in the hands of everyone. That's a key notion to make things scale. Essentially, it's sort of the n-squared problem, where if every single person in this room participates in a blockchain, like a linear blockchain, well, if every one of you creates a message on that blockchain, say spends some money or creates a transaction, the total work done to verify everything scales by n-squared. And the only way to get around that is to not have global consensus, is to somehow split up these transactions in a way that not everyone has to process everything.
So if you have value going from Bitcoin into the Treechains, then I assume you have value going back from the Treechains into Bitcoin. I'm having difficulty seeing how I can avoid knowing what's going on in the Treechain in order to believe the value coming back. And then the second part is this does require a change to the Bitcoin protocol, doesn't it?
Yeah, absolutely it does. That's an interesting question. I don't really know how this will end up getting deployed. One option is, and you'll hear from this later from the Zero Cash presentation, there is some potential cryptography coming down the road where I could essentially prove to you that I did some computation. I don't have to go show you the full data I performed it on, but I can still prove to you that I did it honestly. And if you can do that recursively, well, then the proof that value transferred around a Treechain system can now be ported back to Bitcoin can be a short proof. It can be, say, kilobyte worth of data. How soon will that math get to that point? Who knows? Equally, if you just applied it as in, well, now we're going to have this new system called Treechains where we have this token called a tree or whatever you want to call it, and we can move it around within that system, that can work too. All this is really an open question at this point. And I should stress, very much, showing a presentation like this is not about saying this is something you can invest money in, go and buy my product. It's rather spreading this idea out, because I know for sure that there's no way I'm going to be the only person actually making this system happen. You know, we're going to need a whole lot more, a lot of people thinking about it, and a lot of people kind of working on different levels on it.
Okay, so this is a three-pronged question. First of all, when are we going to see a technical write-up for the Treechains? Second thing is, how much is it fully baked? Like, what's missing from the Treechains idea today, and what development will be needed? How complicated do you think will the development need to be to get the Treechains idea to a full POC?
So there's already the beginnings of technical write-up that was posted a couple months ago on the Bitcoin mailing list. Right now I'm at the stage of writing some initial code to actually manage your tree of chains and, you know, manage the data structures and so on. My first application that I want to actually do is the Bitmessage one, because I think it's very clear to me and other people that this will work and actually do something useful. Beyond that, though, you know, if you're, say, trying to go move value around, there is a lot of open questions. And I don't think I don't think that's going to be a fast process. I think it's going to be at least a couple more months to, you know, show demos of how you could maybe, you know, move value around. Equally at the same time, I mean, these systems for proving to other people that tokens were transferred validly, they look a lot like colored coins. So right now I'm also working on a colored coin client, or in colored coin kernel for another group, so that kind of research is going into that as well. And, you know, if colored coins are successful in Bitcoin, that's the same sort of thinking that goes into eventually making Treechains viable. Equally, I'm sure I'm not going to be the only person who comes up with some of the theory as to how this will actually work and where the attacks are and so on. Okay.
Hi, so I wrote with Aviv Zohar the idea about including the inclusive protocol. And I just want to relate to the scalability issue you mentioned in your regard to Ron's question. So is it true that we aim for all the multiple chains to arrive at consensus? But that doesn't imply that all miners or all block creators process everything. Rather, you let miners randomize over the set of data they need to verify. And if this randomization is good enough, then you essentially get chains that hopefully they will contain different contents. And you know, the main chain that will point at these chains will then just include unique content from all these chains. So we don't fall to the scalability problem of the n square which you mentioned.
Well, I'll point out that actually that's been something, I mean, I've been thinking about too, how to go and randomize verification of chains. And to make a long story short, I never convinced myself I could come up with a randomization scheme that was really robust against attackers. This notion of pushing validation client side always seemed to be much more robust and easier to convince myself that it really would work, if you will, system. And I think there's also a lot of bigger issues around the politics of Bitcoin too, where if you have a system where validation is pushed to clients, well, the questions about how exactly validation should work are taken away. And that can potentially, if it all works, depoliticize how the Bitcoin protocol evolves in the future. Essentially by making it simpler, making there less questions about what you would add or remove to it because it doesn't do as much, and letting implementators of particular systems on top of it make those decisions instead. So I'm not going to say that that's necessarily a bad way of doing things, but I think it seemed to me a higher risk way.
So we hope to provide a security analysis for our scheme. So I hope it will satisfy you. Like,
I sure hope so too, because there's tons of compromises I'm making too.
Okay, great.
You're the one who started working for Bitcoin.
Yeah.
Tell us what you're doing.
Yeah, so Bitcoin's kind of interesting, I think, because my discussions with BTC Drac, who originated the project, I think we really agree on something, which is Bitcoin has the potential to be a better Bitcoin. And equally, Bitcoin has the potential to force Bitcoin to be a better Bitcoin. Right now, the most visible thing I've done is the check lock time verify opcode, which is just a simple opcode that when it executes, it checks what time it is, basically. And if a given time isn't reached, the script fails. And to make a long story short, this lets you go lock funds until either certain conditions are met or some time is reached in the future. And I did that work targeting Bitcoin Core, but our approach there is essentially we write up the code, submit it off to Bitcoin Core as a pull request, give it the peer review, and so on. And depending on how the politics of the Bitcoin Core development go, well, they can either accept it, great. They can reject it, in which case we can implement it ourselves. And in either case, we'll get peer review from that team of developers. So that's a very simple example of how you can go and, with a side project, create new ideas and new features that may or may not go into Bitcoin. Hopefully they do. And that's something we want to do more in the future. I mean, Treechains is kind of the exact opposite in terms of long-term versus short-term thinking. It's a very long-term project, and it'll go move along its own pace. But I think there's going to be a mix of the two that I'll be pursuing.
I think we have some more. My question is not quite technical because, as far as my understanding, you're the only Bitcoin Core developer speaking this convention. So I would like to ask you about your daily job as a Bitcoin Core developer. Can you say a few words about it?
Well, of course, I'll go point out that I'm not one of the, and there are currently, I believe, 3 people whose day job, if you will, is to be a Bitcoin Core developer. And that's, well, actually, no, it'd be really 2 now. It'd be Vladimir and Corey. Frick Corey's last name. But they're both hired by the Bitcoin Foundation to go and be Bitcoin Core developers, and they tend to go do, in case of Vladimir, a review of everyone else's code, and sort of long-term and sort of medium-term thinking about how that code base will go progress. And Gavin Andresen recently stepped down as a developer to focus on, his job title as chief scientist for that. For me, well, for half my work at Vicoin, that's essentially day-to-day. I've got to go and interact with the other Bitcoin developers and review code and so on. And it's kind of a tit-for-tat process where if you don't review their code, they won't review your code. And equally, write up new features. I mean, I think the key thing with all this is it's not really like normal programming work where you spend a lot of time actually writing code and working directly. It tends to be much more about planning and thinking through implications of things, writing up testing. It's sort of a layer removed from necessarily the code itself. Did that answer you?
I think we must speak in person.
I think we're good then. Thank you.